Hi, in this video on harder factorization techniques, we're going to look at an expression which is quadratic in two variables. Now, this expression here, you can see we've got two variables here. We've got A and we've also got B. Now, imagine that instead we had a simple expression where we had 3x squared minus 11x plus 10. So this is a more traditional quadratic form where I've got an x squared term, an x term, and a constant term, a term without any variables in it. And we're going to see that if we can factorize this, we can also factorize this here. How we're going to modify the factorization of this to get the factorization of that more complicated expression. So let's factorize this first. Well, we could split the middle term, but I'm just going to do the quicker way here. And I'm going to assume that you already know how to factorize quadratics where you have a number in front of the x squared that's not 1. So let's just do it the quick way. We're going to do 2 brackets and think what expands to give the 3x squared minus 11x plus 10. Well, it's got to probably be 3x and x because the 3x times x in expansion would give you the 3x squared at the start. We also know that this constant term here times this constant term here has got to multiply to give that plus 10 there. So it could be, for example, 5 and 2. And does that work if I put it either way around? So if I put the 5 here and the 2 here, is there any way I can make the signs work? Yes, if I make them both negative, you can see negative 5 times negative 2 is the plus 10. But you also get minus 5x and minus 6x, which is this minus 11x. So that factorization works. Okay, right, so we factorized this, and let me just move it down a bit because it'll allow me to factorize this thing above. Okay, it's out of the way now. Now, how am I going to factorize this expression above? Well, it's going to be 2 brackets again. And all the numbers that we've got down here, so all the numbers down here, we can reuse in this expression above. So we're going to have the 3 here, we're going to have the minus 5 here, we're going to have, if that's 1x there, we can just put the 1 there and the minus 2 here. So the numbers are all going to be the same. But let's think, instead of x here and here, what do I need to put in these brackets? Well, we can see we need to get 3a squared. This term here multiplied by this term here, if I just have a little arc again. So this term here times this term here has to give the 3a squared, right? So it's got to really be a here and a here because 3a times 1a is 3a squared, right? You can also see that we need to get this 10b squared term here. And the 10 down here was the minus 5 times the minus 2. So to get 10b squared is actually going to be minus 5b multiplied by minus 2b. So this term here times this term here would give you, well, minus 5 times minus 2 is positive 10, and the b times the b would give you the 10b squared. So that's great. This times this will give you the 3a squared, which we want, and the minus 5b times the minus 2b gives you the 10b squared term, which we want. Now, do we also get this minus 11ab in the middle? Well, yes, we do, because, look, if you do minus 5b times 1a, that gives you minus 5ab, and the 3a multiplied by the minus 2b is minus 6ab. So if we have minus 5ab minus 6 lots of ab, that gives you minus 11 lots of ab. So this works. So basically, the strategy here is to just kind of think of this as a normal quadratic with like x squared and x and a constant term, factorize that, and then instead of x, kind of modify it so that we have the variables involved in this particular expression here. So there's a bit of kind of intelligent guesswork, if you like.